you. Good afternoon, ladies and gentlemen. Dear colleague, I would like to thank FAMx for co-organizing this very interesting forum and giving us the opportunity to visit your wonderful country. So I will now focus on the vaccine. The first thing you well know is that and I will switch to French, excuse me. Hein? Voilà. Donc le virus.
So the virus of dengue vaccination as you know, so it's a 50 ARN viruses and the eradication is rather difficult. So one can plan to work out a plan to have these vaccination. For instance, you have vaccine for yellow fever virus and others. So I'm going to very quickly pass through the epidemiology and also talk about the challenges that we have. The first challenge is that with regard to vaccination is that which has been also an object of intense research and with all these 4 serotypes, and second, we don't know what are the correlations and what are the precise protection that one can undertake. So we have to work out answers which be rather protecting in nature and talk about a different serotype. Among these 4 serotypes, we have a high diversity between the 4 distinct serotypes. There is a divergence of 40% in AA sequences that you can see in front of you within even that within the same genotype. In the serotype 2 there is an important diversity, so we may have from time to time an infection per Asian 1 and also by another serotype. So it is not really evident to have the same type of infection caused by the same type of so it is important that we ensure the protection against all serotypes. The second point is the antibodies, and as you know, this is a immunity-based response which has been elicited mostly towards, as you can say, protein 80%, then PRM and NSN1, and which contributes to the construction of the envelope with the help of protein. So the implication is that we need to preserve these structures and with the help of the antibodies and by neutralization, and also for other flaviviruses which we need to neutralize, and also for dengue we know that the protection is important, and certainly the cellular immunity contributes also to the protection. That's something which is not yet very precise. What are the consequences of this co-circulation? That when you do this serotype, then we are going to have an immunity will be against this serotype, and there could be also immunity against others which may last a few months, and that's going to diminish after some time when the second infection arrives, and especially in the face of severe consequences. And what are the physiopathology of this, that is still yet not known. We all thought for a long time that these are the antibodies, but this is a phenomenon which is called as autonomic scene, and as you can see here, the immunity system becomes adaptive, and also after the first infection becomes weak. Instead of the adaptive immunity system, instead of adaptive, and it's going to expand against the first infection. So we have an expansion within the immunity system and with the cytokine, and then which can adapt and which is not able to adapt and become less efficient. So in this context, the research has really moved forward. In fact, you can see all the approaches that we have, and there's plenty of live attenuated approaches in which we see that chimeric YF-Den vaccine, and then approach with subunit vaccine. That is one approach. The approach based on the vaccine on DNA and also inactivated tetravalent vaccine. And I'm going to only talk about mainly what happens at the phase 3. So I'm going to talk about the Sanofi present. This Sanofi approach, the technology is based on a chimeric value of the the viruses, which are made of each other of the four serotypes, and which is the real backbone of this attenuated device. So these are the different images where you can see where this attenuated the live viruses are injected in this, and these are the devices which have been replicated, and then you can see the immunity. So this is the apparatus which has been developed for developing this vaccine, and also these are four different serotypes, and they are frozen and which is used without adjuvant. The result of this dengue vaccine are based on a large development program. There are 25 clinical studies have been carried out, completed 20, ongoing 5, including in CDP, and more than 28,500 subjects have received this vaccine. In fact, there are 5 trials, 5 phases of trial, and there are 14 phases of trials, and then later on 6 phases of stage 3 trials after stage 2. So the phase 1 and 2 are available. So we have a phase 2B which was carried out in Thailand, and between 11 to 14 years, and especially for dengue 2 and 2 phase 2 in the endemic regions, a test which we call SITCAS, which was carried out in Latin America between 9 to 16 years, and then children between 7 to 14 years in the Asia Pacific region. So a baseline has been quite frequented. In fact, 70% of the children already had an infection. So the design was similar for this, as they have received first, you can see the first injection, and the follow-up has continued for 25 months, and Sanofi has discussed with the regulatory bodies, and so that there is no severe result of that, and the second phase was extended 2 to 4 hours, and the main judgment for criteria for judgment was the children had to go to hospital. They were hospitalized, especially for severe form of dengue. So this is an image about the overall efficacy and safety of the COVID-TDV vaccine trials in subjects between 2 to 16 years. You can see reduction in symptomatic with dengue between 56.5 to 60.8, and also reduction in severe disease, which is between 80 to 95%. So there has been a reduction in hospitalization, which is a very important figure, especially for the health services, and 67.2% reduction in hospitalization on dengue cases, which is in the Asia Pacific region. So this may look very good to all of us as a solution, but when you are actually considering all the data, one can ask several questions. First of all, as Dr. Sharma said, we have an efficiency to defend the serotype with an efficiency which is less effective against the serotype 3, and it is, for instance, it may be efficient for SID5 but not for the others. So the other, secondly, we have an efficiency of which is statistically superior for subjects between 2 to 16 years. So 51%, there is no difference, about 30%. Now, overview of long-term follow-up of the COVID-TDV candidate vaccine trials. COVID-TDV group, this is a passive follow-up, and we have had a follow-up for all the children, those who are hospitalized. What has been observed during the phase 3 and that was rather surprising, is that among the small children from 2 to 5 years in Asia, in the third year there was a risk of hospitalization which went up for the dengue, as if the vaccine which is given to the small children was not for the severe cases of dengue, and Sanofi has disputed that with the health authorities. It is more hemorrhagical dengue than the severe dengue. And the vaccination, as you see in the middle, for the age group of 6 to 11 years and then 12 to 14 years. And besides, in the tests which were carried out in South America, so there were older subjects, and there was a persistence overall in the overall follow-up. So that follow-up is carrying on still, and all these results that we have, when we look at the reduction in hospitalization for VCD, any severity in subjects for more or less 9 years of age, in pooled data at year 3. So we can see the 3 different groups, all ages, less than 9 years, then 29 years non of age. And for children less than 9 years, so one can discuss the result, and Sanofi has discussed this matter, and for the timing to submit a file for children who are more or less of 9 years of age. So these are all the questions have really given birth to a lot of discussion in the scientific community. For instance, that why better response for some and why not, and several questions were asked, and I'm going to take up a few of them. Why the response is better after priming, which is not capable of create an immunity. So this is a vaccine which is going to be useful in the endemic regions where children attain dengue at a very early age. I mean, for us in France, in the mainland France, and for the workers, the second question important, that why there's low efficacy toward DEMD 2. You have seen that this is something which is really very variable. It may be possible, but it is not yet proven that there could be a mismatch between the initial virus and the circulating virus. So there could be also the interference of the 4 viruses. It's an area on which we are working. In the vaccine research of dengue, we need to check properly the genetic composition of the virus, so that we can deal with them in adequate manner. The close surveillance or the close monitoring is important. The third question, that why there is so poor correlation between the cutoff of NUT AB and protection. So that means there is a discordant position here between the two, and between the protection and the NUT AB. So what are the tests? So these are the antibody-based test, or are neutralizing antibodies measures a good as a good correlation between the protection, and what is the benchmark? What is really the entry-level mark? And another question that needs to be answered is why there is an increased risk of hospitalization for dengue, especially for younger children. What is good to know is that these are not really the very aggressive type of dengue. There is a cluster of group, and all the children who are doing their priming. In the 3 follow-up years, they had the second infection. In the group which was controlled, so they are going to do their priming at 2 years, 3 years, or 4 years, and the second infection later on. For Sanofi, so this was a transitory phase. So we requested them to take a look once again after 2 years, and after 2 years they were not at a high level risk, and this demanded a proper investigation. So this is what I just wanted to share with you regarding the Sanofi vaccine. So there are other teams those are also working for the, as you can see, the recombinant chimeric vaccine, which have been developed in Thailand. The phase 2 trial is going on. The live attenuated vaccines, that's the other type. Quaternary structures, and the tests in the phase 2 trial is going on in Brazil and also in Thailand. So there's one more version, which is the recombinant subunit vaccine, and we don't know whether we will be able to get the antibodies for that. There is an approach, so it is the inactivated tetravalent vaccine, which is not really giving that high level of antibody, rather low antibody. We need to have a synergistic formulation for that. And then the monovalent DNA plasmid, which is very efficient on rats and non-infectious and low immunogenicity. In India, I have not really found the candidates, but there are several companies and those who are working especially with the help of, in collaboration with United States, to start the vaccine trials. In conclusion, I think we are rather clear that we have certain challenges which are extremely specific, especially for these 4 serotypes. In fact, after the first infection, there is a lack of full knowledge, and in spite of that, there has been a great deal of advancement that has been carried out with regard to these vaccines. As you can see, the vaccine efficiency in phase 3 randomized trials reducing to 56 to 60% of dengue fever cases and 80 to 90% severe dengue cases. Better efficiency in previously seropositive subjects and in children for less than 9 years. And this explains that we are really working on this dossier with Sanofi of some weeks back, especially in the endemic region, so especially for children with more than 9 years of old. So there are other elements also, and registration files have been submitted. And thank you very much for your attention.
Thank you very much. Merci Dominique. Je pense que tous les 4 orateurs peuvent respecter le temps de parole. Donc, nous pouvons avoir 2 ou 3 questions. Est-ce qu'il y a des questions? Oui, une question. Si vous regardez les données indiennes, les types que nous connaissons ici, depuis 1996 jusqu'en 2015, c'est du type Dengue 2. Et si vous examinez les États indiens qui ont une charge élevée de dengue, sauf pour l'Uttar Pradesh, tous les États à charge lourde montrent aussi le dengue. Donc, c'est quelque chose d'important. Je pense que ce sera également constaté par l'OMS. Quelles sont les implications pour l'Inde? Nous avons le dengue 2. Qu'est-ce que ce serait utile dans le contexte indien? Je pense que ça pourrait être utile dans le contexte indien Je pense que le stéréotype change d'une année à l'autre. Parfois, c'est deux, un ou trois depuis 2 ans. Il y a beaucoup de dengue. En 2013, c'était dengue 1. Si vous examinez les enfants ayant plus de 9 ans, la séroprotection marche bien. C'est moins protectif dans le cas de dengue 2, mais par rapport aux autres sérotypes, mais les enfants de plus de 9 ans, elle protège. Ce serait intéressant d'avoir un vaccin qui réduit l'hospitalisation dans le cas sévère de dengue. Ce n'est pas le vaccin définitif. Nous avons beaucoup plus de preuves, d'évidence. Donc, il faut attendre la démarche suivante. Le vaccin Sanofi n'était pas efficace chez les enfants moins de 7 ans. J'ai lu l'éditorial et les commentaires, ce qui dit que le taux d'infection était plus commun, c'est généralisé chez les enfants de moins de 7 ans. Mais est-ce que vous pouvez expliquer? Probablement chez les enfants moins âgés, c'était moins efficace. Les enfants moins âgés devaient être hospitalisés plus. Il y a 2 facteurs de l'immunogénicité. La séropositivité et les jeunes enfants présentent les deux. D'autres questions? Je vous remercie, Dominique. Maintenant, une pause.